will be presented by Florence Libotte and Mercedes Correa. Could you please stop sharing and prepare for the next talk?
Okay.
So, those are amateur astronomers and made very interesting and useful work using the Europlanet telescope network.
Okay. Hi, Gazina. Do you see my presentation?
But not in the full.
Not in the full? Just a second. Presentation. Now?
Now it's okay.
It's okay?
Yes.
Okay. Okay, let's begin then. A pleasure to be with you to explain our our amateur observation of the exoplanet WASP-156B with the EPN-TN. EPN is the logo that you see down below the Europlanet telescope network. So, well, let me begin by the end. This is the webpage of the IAC. They published the transit that we will talk about in their news. I translate their web. They say the telescope IAC 80, which is a 80 centimeters telescope, detect the weak transit of the exoplanet WASP-156B. The key word there is weak. How weak? Well, that was the reason for this publication. It was only a 6 millimagnitude depth transit. Well, how did we get there? First, Mercedes Correa and myself, we are both observers. Normally, we used to observe variable stars. Mercedes has her own observatory in the north of Spain. You can see it here. It's a 12-inch telescope. And on my side, I use the telescope. It's a 50 centimeters telescope from the Association of Sabadell. It's an amateur astronomer association. Well, we get involved in the exoplanet observation through a workshop that took place in Spain, also in Calaralto. We connected in live with the telescope. It's a 1.2 meter telescope. And we also had the explanation on the Europlanet network, how to get time on their telescopes and how to get money for funding. We receive funding for those nights because these works belong to the Ariel mission, and the exoplanet transit objectives is to determine or to better determine the ephemeris of the exoplanets. So this was the result of that night. It was in May last year. It was the WASP-14B. And after that, well, Mercè and myself, first we thought that we could try to enter into this project. So first, the process was to look for targets. We look for high priority exoplanets. That means that there were few measures in those cases. Or alert exoplanet also. Alert means that there are a lot of inaccuracies in the ephemeris. The O-C varies very much. For this, we use these 3 pages, web pages for scheduling the session. Here you have an example of those ones. You can see ExoWorld Spies, and you see the name of the exoplanet. And every exoplanet is classified as high priority, medium priority, low priority, and it gives you the time of the transit, at what time you have to begin the observation, at what time in the end, and you can prepare. So we offer to the IAC 80, to the Canary Island Astrophysics Institute, 4 nights And they said, well, in those 4 objects you mentioned, we can help you with one of them. So even though the delay was over to get time for the month of October, we were in August or something like that, they exceptionally free 1 night for our observation. We chose 2 exoplanets, the WASP-156B and the Corot-10B. We must say that the Corot-10B, that was the first observed exoplanet in the night, but it was very soon after the twilight. The moon was there, and also it was our first experience, and the result is not, we could not take any data, useful data from the observation. But on the contrary, on the WASP-156B, that was a little bit later in the night, yes, you will see with Mercè that we could get a really good result. WASP-156B is a super Neptune type exoplanet. It was considered at that time as a high priority because there was only 1 measure. And the magnitude of the star is about 11.6 in R. And the depth, as I mentioned to you at the beginning, only 6 millimagnitudes. So we followed the process by presenting the formal requests to the observatory at the Canary Island with a scientific justification where we explained the Ariel mission, the object to observe, the conditions that we were wanting, the filter, and so on, a scientific justification of 2 pages maximum. We discussed quite a lot the time of exposition because, well, it's a professional telescope. They have a calculator, the Camelot calculator. Camelot is the name of the CCD of that telescope. They have a calculator that helps you to fix either the signal to noise or the time of exposition. We chose to fix the signal to noise in our case. After that, we had to present also the formal request for funding at the Europlanet. It's about the same kind of information as the scientific justification for the observatory. There we have 3 pages maximum. And in that case, the night cost 800 euros. This is to give you an idea of how the formal request looks like. This is it. And we wait for approval. We get it. We got the approval. Then we were required that after the D-Day, that was the 15th of October, we had to present a report very quickly, very shortly after the observation. And well, we expect the D-Day and we cross the fingers in order to get clear skies for that night. Well, now Mercè will take you to the D-Day, or let's say the D-Night, and the hard work afterwards. Mercè, please go on.
Okay, if you finish you sharing your screen and I share mine. One moment. So I think we were here. Just a moment. You can see the whole screen? No? Yes. Oh, it's not the right one, sorry. It's number 13. Okay. So finally, we arrived to this night. We were very exciting because our experience or exoplanet observation was really very, very short. So I did an observation before in my own observatory, but okay, it was quite good, but well, we were really not experimental on this. So for us was a very exciting night. We first contacted the the team operators of the telescope, Marta and Miguel, because this telescope is working on service. So you are not conducting all the observation. There is a team in the telescope that is doing everything for you. So we were discussing the problem, as Florence explained, was the Corot transit was beginning very, very early, just after twilight. And from the very beginning, we saw that could be very difficult, this observation. For this reason, we scheduled the second object as a B plan. Yeah? So we began with this observation of Corot, but this then we did a Zoom connection with the team, trying to discuss to better obtain a better result with the second object. In this case, they offered to us they were not convinced that we will get these 6 millimagnitudes in the transit. So they offered to us to defocus a little the images, spreading the signal into more pixels, and then we can maybe arrive to this good result. And we agree with this. So we put up the signal to noise, but defocusing. When Corot 10B ends, we focus to the second object, and it was at 0 UT, and it ends 4:40 UT, but we were not all the night awake. We only stayed till 0:40. So the day after, we obtained from the observatory 119 images in each filter. We use eye and air filter. Each image weighs a lot. And here you can see some of the characteristics of the Camelot 2, the CCD in this telescope. As you can see, the images have some part, the edge of the images have some out of field pixels. And later, you will see it could be a problem. So we began analyzing our data with the software HOPS. HOPS is the software used and offered by Exoclock for analyzing these transits. We have to say that really it is very easy to use, or quite easy to use. It's friendly to use. So you can get the software in this website. And we had, as I said, some problems with this out of field of view. We had to contact Angelo Ciaras from Exoclock, explaining that the alignment with HOPS was not running with these images. So he helped us a lot, did a new version of HOPS, introducing a subframe to crop the images and save this problem. The images also had an additional problem, that was the exposure time was not saved as text, but as numbers. And he fixed also this in HOPS to be able to analyze our images. Well, for the photometry, we tried to choose the best comparison stars. Some of them are too faint, but there are not so many in the field. So we did several trials. And finally, we were quite confident on our result and sent to Exoclock database. And this is the result published. On the left is with eye filter, on the right with air filter. I have to say this work was done with our group, some people of our group in Sabadell, Josep Maria Vilalta, Albert Morral, and Telp Ginard, who is attending this workshop today also. And we were very happy with the result, especially because we were not so experienced on exoplanet observations. And well, it's the main objective of our talk. We have learned a lot in this session. We learn how important it is to choose the adequate target for the telescope that you have available and the night. For example, Corot was not a good target for that night because too much moon and we have no time to really adequate signal to noise, exposure time, and these things. Also, it's important to choose the right comparison stars, trying to get ones with similar color, if possible, and similar flux. This most of the times is not possible, but you have to try. And also to do photometry several times until you get a satisfactory result. And if you get problems, as we got, ask for help. In this case, we thank you very much to Anastasia and to Angelos, especially from Exoclock, because without his help, we didn't arrive to the good result. And our conclusion is that this is a wonderful network of telescopes that are to your disposal, to our disposal. This for me is amazing for us. And then I think is a call to all the amateurs and students to use it. Yeah, it's a very good network with different types of telescopes, different CCDs, so you can adapt to your objects. Yeah. So the request filling process, as Florence showed before, is quite easy, even for amateurs or students. Maybe you have to look some bibliography for do the scientific justification, but it's not so difficult. And there are many possibilities to obtain time in these telescopes, in this network, as I think only few amateur proposals has been presented, at least when we presented our proposal. And also we think the professionals are always there to help when you have a problem, when you need. So we encourage all of you to apply for time for these telescopes and try. That's all.
Thank you, Florence and Mercedes, for your great work. I could not imagine a better advertisement of this telescope network. You made the great work, learned a lot, and are very good examples for other amateurs and other who wish to investigate exoplanets or other objects. Do we have questions?
A comment from Ricardo Hueso.
There are some notes in the chat. I was so impressed by the presentation, so I did not read. So maybe you could ask.
It was just a very short comment that I'm very glad that these observations were finally made, and they were so good that they are providing these good results for a mission like Ariel in the future. And this is the kind of things that we want to do in the Europlanet Telescope Network. We want to get more people involved in these big projects, and also amateurs. And it's good to see that amateurs can get involved and enjoy doing these observations and getting these great results. It's just a congratulations to you two and the rest of the team that I know it's involved with more people doing the analysis and really playing with the data. Thank you.
Gracias. Thank you.
Thank you to you, because the first workshop in May was the one that encouraged us to do it.
So John Davis asked a question.
Yeah, I really didn't want to ask a question. I just wanted to say pretty much exactly what Ricardo said. I'm an amateur astronomer who became a professional astronomer, and that was a great piece of work and a great presentation and an absolute advert for this network. It was fabulous, and I commend you to the skies for what you did. It's super.
Well, thank you, John. Thank you so much.
So thank you